Math modeling, 4.8 scientific notation. Goal: I can read and write numbers using scientific notation. What is scientific notation? Scientific notation is a way of expressing really big numbers or really small numbers. It is most often used in scientific calculations where the analysis must be very precise. This is something you need to get in your notes. In your own words is fine. It would be a good idea to pause the slides and put it into your own words. Hit play when you are ready. Scientific notation consists of two parts. It is a number between 1 and 10, and it is a power of 10. It can be expressed as n times 10 to the x power. To change from standard form to scientific notation, we place the decimal point so that there is one non-zero digit to the left of the decimal point. Notice that that is a one non-zero digit to the left of the decimal point. We then count the number of decimal places the decimal point has moved from the original number. This will be the exponent on the 10. Continued from the previous slide, we add that if the original number was less than 1, the exponent is negative. If the original number is greater than 1, then the exponent is positive. Again, pause, get these down, and then we'll continue on. Here we're going to convert from scientific notation to standard form. I'm sorry, we're going from standard form into scientific notation. So, our decimal, you will notice, is here. We're going to count 1, 2, 3, 4, 5, 6, 7 places over to get our number into the position that it needs to be. So we write 7 2/10 times 10, and then we count the number of times we had to move our decimal. So the decimal moved from a number less than 1, so it will be negative, and it moved 7 places, 1, 2, 3, 4, 5, 6, 7 places over. So our new number in scientific notation is 7 2/10 times 10 to the negative 7th power. On the next one, we're going to place our decimal point between the 4 and the 8 because it would have been back here behind the 0. So we will count over the number of places, 1, 2, 3, 4, 5. So we get 4 8/10 times 10 to the 5th. And now we have one remaining. We go 1, 2, and it's going to be negative, and it's 9 times 10 to the negative 2nd. I'm sorry, I forgot the other parts to that one. 9 and 83/100 times 10 to the negative 2nd. The 83 remain behind the decimal. That's why we don't worry about those two. Okay, moving on to the next slide. If you need to pause for a break to catch up or review, feel free. You can always rewind if you need to. Next, we're going to change from scientific notation to standard form. Here we simply move the decimal point to the right for the positive exponent 10. We move the decimal point to the left for negative exponent 10. Use zeros to fill in the places. Convert the following numbers from scientific notation into standard form. So we have 489. We already moved 2 places. We're moving 7 total. So we need 1, 2, 3. We've got 1, 2. The 8 and 9 are the first 2. Then we've got 3 more zeros, so that gives us 5, 6, 7. And then it always helps to go back and put in the commas in the correct places. So we've got 48,900,000. Next, we have 1.4, 1 4/10 times 10 to the negative 8. So we're going to have a lot of zeros moving to the left. So we start with our 4 and our 1, and we're going to, and it helps, I like to put in the actual 1, 2, 3, 4, 5, 6, 7, 8. And I didn't give myself enough room, but that's okay. 1, 2, 3, 4, 5, 6, 7. Because this one counted as my first, the 1 counted as my first. So my decimal goes there. You can see looking at that why scientific notation is a helpful way of writing numbers. That looks a lot easier than writing it out with all those zeros with that decimal. All right, next we have 3 789 thousandths times 10 to the 5th. So we're going to do 3 789 thousandths, but we really don't need to worry about the thousandths. We're going to move that 1, so we can move here 1, 2, 3 behind the 9, 4, 5. So we need to add 2 more zeros. So we've got that 378,900. Okay, if you need to pause to reflect or look at that again, feel free to rewind. Okay, now we're going to analyze, are the following numbers in scientific notation? Why or why not? And the first one we're going to look at is 29 times 10 to the 9th power. And the answer to that one is no. And hopefully you understand, because 29 is not a number between 1 and 10. 2 9/10 times 10 to the 3 4/10 power. Well, hopefully you realize that 3 4/10 power is not a power we work with. So that is no. And lastly, we have 2 9/10 times 10 to the negative 17th power. And that is yes. That is the way we have been looking at our powers. This concludes our lesson for today on scientific notation. If you have any questions, please make sure you've written them down so we can go over them when you report to class tomorrow. I hope you've enjoyed our first lesson on flipping the classroom doing scientific notation. I look forward to our lesson in class tomorrow. Thank you and have a nice evening.